Hello. Yep. Can you hear me? Okay, let's get started. So in the lab 2, we are going to discover the signal strength and the noise, and try to use the Wireshark to analyze the trace file. So in the task 1, but before we do this lab, we should complete the lab 1, so which is the environmental setup. So I assume everyone can capture the signal strength right now. Is that correct? In the Wireshark. Okay, so the task 1 should be pretty easy. So in here, you just click this link, and we will go to this. You can get this file and open this one with your Wireshark. So you can see it like this. So in your Wireshark data interface, the layout could be different because I applied some extra column in here. Let me delete it right now. So your layout should be like this. So the first thing we need to do is to apply a filter. As you can see here, this is a trace file collected by the monitor mode. You can see in here. The first thing we need to do is to apply a filter with this, because this one is capturing monitor mode, which means we have 3 devices. Let me open the drawer. So this is our device, and we have another AP, and we have some clients. Should be something like this. So the AP is the hotspot, could be the Wi-Fi, and they are communicating with the client like this. And if we turn on the monitor mode, then our computer will be able to capture all the traffic between these clients and AP. So for example, if we have a packet from AP to the client, and our device will be like stand in the middle and can sniff this packet in the middle side. Yeah, AP is access point. You can consider as a Wi-Fi. Okay, so this trace file is captured by like this. So our device is standing in the middle and did not connect to any Wi-Fi AP access point. So we are not connecting with this Wi-Fi access point. So we just stand here and use our network interface to capture all the packets we can get from the air. So as you can see here, the source IP and the destination IP in here will not have our own IP because we have not connect to any access point. So as you can see here, this one could be a Apple client, and this one could be the like router or something like that. as you can see, this one, Netgear, probably is a Wi-Fi router, and it's doing a broadcast. Okay, so our first task is to apply a filter. As you can see here, there are lots of packets, but we only care about the SSID related to this one. So how can we apply this filter? You may need to type something here, probably SSID stuff, SSID, but you can see the syntax is a problem because we don't know how to like apply this kind of syntax in the filter, and this one is not working. So what should we do? All right. So in here, I have teach you in the previous lab, just find the SSID in the detail area in here. So you just click this one, beacon frame, and the wireless management stuff, and try to figure out where is the SSID value. It's in here, right? So we just right click it and apply as a filter in here, as you can see. So we don't need to learn the syntax. We just click our mouse. So after we apply the filter, you can see all the packets are related to this like Wi-Fi access point. So what should we do next? We need to plot the signal strength and noise and signal to noise ratio. So in here, probably we need to use like Excel or Python to do the plotting stuff. So in here, we need to output the file, because if we are using Excel or using Python or other kind of stuff to plot the graph, we need to let the software or the language to read this file. So we want to output as a CSV file, right? In here, or as a JSON file, whatever you want. So I just click this one and save lab2 1. And let's try to open this one. So after you open this one, you figure out how can we get the signal strength and the noise. There's no this kind of information, right? So before we output as a CSV file, we need to come to here, add some column in here. So we need to apply the SSID. So it's in here, SSID, and the signal strength is in here. Apply as a column here. So we need to add some new column in here so we can output this kind of data. So we just right click it, apply as a filter. No, apply as a column. And the ratio, apply as a column. So you can see now we have 3 new columns and it's ready to output. So output again as a new lab file, CSV file. Then we can open this new one. See if we can get a, yes. So now we have the signal strength, noise level, and signal to noise ratio. And then we can start to plot. So in here, I will show you with the Python. So I just open the Okay, so in here, we want to load the CSV file at first, right? So the first step is to load the CSV file. Pandas, data frame, go to the pandas, read CSV, and the file name is lab2.csv. So we can show the data frame. So we read the whole spreadsheet at first and try to plot this kind of stuff. So because we want to plot this one at first, so it could be we need to convert this string into the digit at first. So df, so we want to apply something. Probably we need to import a new library called regular expression. So we want to convert this one to float. So apply lambda and search digits inside this one. Yeah, so we need to group 1, group 0. Okay, so now we extract the digits from this string, right? And we give it a new value, save it as a new column. So we just call it df signal strings. So we have a new signal strings column right now. So basically just extract this number to here. And now we can plot it. So df plot the axis should be time or number, could be fine. And the y axis is SS. And the kind of plot should be line, I guess. Oh, it's not working. Sorry, let me check. So df plot, what is the problem here? Oh, I see. So this one is still string in here. So we can have a double check. This one is the object, so it's a string. So we need to apply a float outside of it. So float convert this one into float instead of a string. So we just run it again. Okay, now you can see it's in here. So that's how we plot the value change of signal strings. Does the negative sign matter? Yes, it does matter. So you will remind me. So probably I need to add a minus here. So it could be like this. So I convert this one into negative. Can you show us how to do this with Excel? Yes. So in the Excel in here, so you open the file like this, right? And the idea is the same. The logic is the same. So firstly, we want to extract the minus 26 from this column, right? How can we do that? Sorry, my Excel is that. Give me a few seconds. So we want to split this column at first. So we go to data and text to columns and click it. Then you can use the delimited. And next, use the space to split the column, right? So click next And we can drop this to line. How can we drop it? Okay, I don't know, but let's just get this done. And uh, be it. No, let's just get this done. And yes, then you can see we extract the first thing out, but we lost the noise and other stuff. Never mind. Let's just get this one first. And then we select these two columns and insert could be a line. So the plot have some problem right now. So we need to change the data source or something. Select data. Switch. Nope. It's a little bit hard. Let me try another way. I just copy this one to a new stuff here and try to insert a line. No. Insert. How about I remove the time? Yep. Okay, so it could be something like this. So it's the similar idea as Python. So I'm not that familiar with the Excel. Probably we need to figure out a way to set out the x-axis. Yeah, so no matter which kind of method are you using, just finally get this kind of graph. So in here, I only show you how to do the signal strength, and you need to do the noise and SNR with yourself. Maybe scatter plotting. So yeah, yes, you can use every kind of plot if you want. Let me try. So, yeah. Yeah. So try to do this one right now if you can. So if you have any trouble, just let me know. So that's the task one. We need to plot these three graphs. You can plot it in separate graph or in one graph. That's fine. But do remember to apply this filter at first. Otherwise, you will get another kind of graph. How do you remove the top part in Excel? Let me check. The top part, is it this one? You had a blue line before. Okay, I see. So at first, I was trying to choose the time as x-axis and the signal strength as y-axis. So I just choose these two stuff, right? So you can see the time is in the blue line and the signal strength is in the orange line. So I figure out probably I should not choose the time in here. So I just deselect it and then press OK and it's gone. I just delete it. But the x-axis is still the number of packets. It's not the it's better to show in the time like with the time. So we need to figure out a way to show with the time as the x-axis. Nope. Can we have signal strength noise? Yes, but if you can, try to merge them into one graph, like put them all together in one graph with different color. That should be easier to like have a look. So you can play around with it by yourself. It should not be very hard. So that's task one. And the second one, you need to write a short commentary about your observation. So as you can see, I can give you a hint in here. The trace was collected while the mobile phone was moved away from the laptop slowly, then moved back close to it again. So this one is very important. Let me show you the graph again. So this is the graph. So the trace file was collected. Firstly, like the mobile phone is very close to the laptop, right? And it slowly move away from the laptop. So you can see the signal strength is decreasing. And then move back close to it again. You can see the signal strength is increasing in here. So that's mean the distance is decreasing. And it move away once again. As you can see, move away and move back. So just write down your observation in here. Also, you need to have a look of the noise and signal to noise ratio, but they should have the similar pattern. My results range between 20 to 50 since my results. Yes. So you're asking the question related to the task 2, right? So this is task 1. Just plot this graph and write a report. And in the second task, we need to do this kind of stuff with our own cell phone. So we need to capture and analyze the trace file by ourselves. Yeah, so this one, firstly, we need to use our mobile phone to create a Wi-Fi hotspot. So if you have trouble in here, just let me know and I can give you some instruction. But I think it's pretty easy. Just go to the setting. If you are using the iPhone, go to the setting and it should be in the personal hotspot and change your the name of the SSID to this one, to your USWT ID. So you need to change the name in the setting. But usually we will lose this information when we capture this kind of stuff, because most of our students are using Windows. So you may not be able to capture the ZID in the trace file. So don't worry too much, just mention this in your report. So you have tried to like change the SSID to your ZID, but you cannot capture it, that's fine. And just connect to your laptop with the Wireshark, because I'm like streaming right now. So I'm not able to show how to do this to you, but just let me know if you have any trouble. Simply create a hotspot and connect it with your laptop. And then we can use the Wireshark. If you are using a Linux or Mac OS, just come to here and simply select the interface as Wi-Fi if you have already connected, and then you can start. If you are using a Windows, then we may need to use this one, Microsoft Network Monitor. So you just come to here, select the Wi-Fi, and then we can start to capture. In here, just click the start button. So before you start, make sure you have connected to the correct Wi-Fi, which is your mobile phone hotspot. And you can just click the start, then you can start to capture the packet. You can have a double check of the BSS ID or the name of the Wi-Fi. And also, if you want to increase the traffic, you can try to play a song or play a video in YouTube. So you can increase the traffic between your mobile phone and your computer. And after like 1 minute or 2 minutes, click the stop and output save as, saving the app to. And after we save it, then we can open it with the Wireshark. So it's the same idea here, because as you can see here, my interface can only capture the signal strength in here. There's no noise level, and there's no signal to noise ratio as well. So we cannot fix this problem because it's the limitation of the like network interface. So this is okay. Just try to do your best. So at least you can get the signal strength. So you just plot this one. But if you do like figure out how to capture the noise level or signal to noise ratio, just plot it to a graph as well. So if you are using a Linux or Raspberry Pi, then you should be able to capture the noise level and signal to noise ratio. But in here, if you are like have the same situation as me, don't worry too much. Just mention this in your report. That's that I'm using like Windows and my interface is blah blah blah, and I cannot capture the noise level and signal strength, signal to noise ratio. And then you will be fine. Just plot this one. And also you can mention like, how did you collect this one? Like while Wi-Fi is being captured, move the mobile phone as follows. You need to move it away slowly and then move it back. So we should have a similar pattern, like move it away. So move it away should be like this. We can see a downtrend, and move it back and we can see the uptrend, and like that. So you should have a V curve in your task too. My results range between 20 to 50. That's fine. So it doesn't really matter what is the value of it. Or some interface have like the positive value. It's also fine, which means your like signal strength is very strong. But usually it will be a negative value, because when it reaches to 0, which means it's like super powerful, probably it's the like the units is different in your interface. So usually we cannot find the value exceed 0. So it will always be negative. Yeah, or you are capturing the ISSI. I don't know. So using what Python or Excel doesn't really matter because we are not asking you to upload the upload the code or something. We all we need is this plot. Okay, and yeah, that's all. So in task 2, you just upload the capture file and then also put this kind of graph in your report and write a commentary. So that's all we to do in task 1 and task 2. So you need to submit a PDF report for task 1 and task 2. Basically just 3 graphs and the commentary. In here, we mentioned that you need to submit 3 graphs. So you don't need to worry about how to merge it. Just generate 3 different graphs. And in the next one, it should be the zip file. For the task 1, you need to submit the CSV file like I did in here. So just submit this file. It should contain the signal strength, noise, signal to noise ratio. Submit this CSV file. And you can also plot the graph inside the CSV file. That's fine. And also submit the CSV file and the trace file in task 2. So in task 2, you are going to collect the trace file by yourself and analyze it as we did in task 1. Yes, that's fine. Just as long as you plot all the 3 stuff we need, you can put it in like 1 graph or 2 graph, doesn't really matter. That's fine. Does the plot need to be formatted nicely? Yes, if you can, try your best to make it like look better. Yeah, just let me know if you have any doubt. And yeah, today's lab is pretty easy, like in my point of view. So try to do it right now. And if you have any problem, you can let me know because we still have about 1 hour. So that's basically all the thing we have for today. Yeah, try to do it by yourself right now so I can help you if you have any issue. And how is the quiz last week? Is it very hard, like a lot of computation? Like how is the outcome? Yeah, the time is very limited. So that's the reason we need to like have a look before we attend the quiz. Probably we need to have a look of the recording or the slides. Yeah, and for week 1 and week 2 is the hardest. So it's lots of computation, but after week 2 should be like easier, especially for the last 2 week. It's around like some security or some advanced cutting edge technologies. So there's not much computation. It's just basically some theory. So don't worry too much because how many quiz we have? I think we have 9, right? And only best 6 of it will be counted. So just try your best. Okay, then let me stop the sharing. So if you have the any question, so you can share your screen.